Hi, so we're going to continue on with some laws of exponents, and in that previous video that you maybe just watched, you would have seen that there's a property to maybe a shortcut when multiplying values with exponents that have the same base. So we looked at an example somewhat like this, 3 to the 5 times 3 squared. And since the bases are the same, they're both 3's, then what we can do is apply this multiplication property where we say, well, that becomes 3 to the 5 plus 2, and we add the exponents, which is the same as 3 to the 7. And if you were to evaluate these out with your calculator or even by hand and then multiply the two values together, you would see that you get the same value as 3 to the 7, which is, let me just do this on my calculator, 2,187. Okay, so this was covered in the last video. Also, you saw something where if I took my same one, maybe 3 to the 5, and raised that whole thing to the power of 2. This is a power law for exponents, and the shortcut is to multiply these two exponents together, where that becomes 3 to the 5 times 2, which is 3 to the 10. Okay. One of the things that was missed in that video is a quotient rule. So I want to show you just what to do with quotients as opposed to products and powers. So first of all, what's a quotient? Quotient is what you achieve when you divide some numbers. So, say we have something like 3 to the 5, and we are going to divide it by 3 squared rather than multiply like before. It might be more helpful to view this in a different way. This is the same as 3 to the 5 divided by 3 to the 2. Okay, let's write this one out and look at what happens. 3 to the 5, what does that mean again? That means multiply 3 by itself 5 times. So 3 times 3 times 3 times 3 times 3. And I've got 5, 1, 2, 3, 4, 5, all divided by 3 squared, 3 times 3. All right. Now, normally when we divide, one of the things you want to do is just cancel. Since these are all products getting multiplied together, let's do some canceling. This cancels with this cancels with this, and I have finished any canceling. When I've canceled everything in the denominator, what's left over? Not a 0, just remember that it's a 1. Everything is canceled out to be a 1. And what do we have left in this numerator? 3 times 3 times 3. What's another way to write that? Thinking about exponents. Well, 3 is the base. How many times are we multiplying 3 by itself? 3. So we don't need to write over 1. This could just become 3 cubed. Now, looking back, let's figure out a shortcut. What happens here? What have we kind of done? We've taken our 5 3's and divided by 2 3's, in the sense canceling, or what else? Maybe subtracting as opposed to adding, which we did up in here. So we can say that 3 to the 5 divided by 3 squared is the same as doing 3 to the 5 minus 2, which is equal to 3 cubed. Okay? Or in general, a to the n, m, let's write m, over a to the n is a to the m minus n. Alright, so if 3, whoops, we need to put a pen going here. Okay. If 3 to the 5 divided by 3 to the 2 equals 3 to the 3, then what does it look like if I switch this around and I look at 3 squared divided by 3 to the 5? Well, if we apply the same law, that means we have to subtract the exponents. This becomes 3 to the 2 minus 5. And that becomes 3 to the minus 3, because 2 minus 5 is minus 3. How does that look if we write it out in the long way? So 3 times 3 over 3 times 3 times 3 times 3 times 3. We start doing our canceling again. That cancels with that, and that one cancels with that, leaving me a 1 up here. And that's equal to 1 over 3 cubed. So, but these two things must be equal to each other because I've done what's logical but two different ways. And this is true. This is true. 3 to the minus 3 is equal to 1 over 3 to the positive 3. In general, a to the minus n is equal to 1 over a to the positive n. Okay? So if we end up with a negative exponent, it's not customary to leave exponents as negatives, but to take the reciprocal of a, which is 1 over a, and change the exponent to a positive. This also works in the reverse, that a to the n equals 1 over a to the minus n. Not very likely that you will go in this route because this is already positive and we'll probably leave it like that. Okay? Another way to think about it is, since this is a over a to the minus n over 1, I put my base in the other area of the fraction, which from numerator down to denominator, and change the exponent to positive. It became down here. We need to leave a 1 on top. Let's look at a few other examples of that. So if I have 2 to the minus 4, that's, if I follow this rule, is the same as 1 over 2 to the positive 4. How about 3x to the minus 5? And I need to write this with positive exponents only. Remember that this minus 5 is only on the x, not on the 3. This is a 3 to the positive 1, which is not written. So think of these as factors. We separate them. There's a multiplication going on between them. That's 3 to the 1. This part, let's put a different color around it so you can see it. Right here is how we are applying this principle up here to it, okay? So that becomes over and then x, but to the positive 5, okay? Or just 3 over x to the 5. Okay, so we don't want to be mistakenly taking that 3 down to the denominator because it's to the positive 1. Only x is to the negative exponent, so it moves. Okay, one more big one. Let's look at 2y to the 4, z to the minus 2. Write with positive exponents only. All right, so have a look. 3 different factors. Got a product multiplication going on in between. So this is equal to 2 to the 1, that's a positive exponent, times y to the 4, that's a positive exponent, times, how do I write that again with a positive exponent? 1 over z to the positive 2. Right? So really just this part right here transforms into this part right here. The rest kind of stayed the same. Now, remember too, that's over 1 and that's over 1. And when we go to multiply fractions, we should multiply numerator times numerator times numerator. So 2 times y to the 4 times 1 all over 1 times z squared. And those 1's are a little bit silly in there, so that's really just 2y to the 4 over z this squared. So what really just happened in here? We left anything with a positive exponent in the numerator where it already was, and we took any base with a negative exponent to the denominator and made it a positive exponent. So that's kind of a general rule. Okay, please try some practice, and hopefully this goes okay for you. See you in the next video.